what is the definition of life, first of all? And then my friend Freeman Dyson, who I've talked about as a physicist, has argued that we all talk about replication as if it's the thing that defines life, but maybe it's metabolism. Maybe we're in the total wrong direction. So if we think about the origin of life, what is life? What defines the difference between life and non-life? And is it replication or metabolism that's more important?
There is no obligation on us to come up with a definition of life.
Sure.
It doesn't matter. You could regard it as a semantic question. You could say, some people would say viruses are alive and other people would say viruses are not alive. I don't care. It's a bit like saying, is Pluto a planet? I mean, who cares whether Pluto's a planet? It's the same with life. You don't, as long as nothing turns on it, it doesn't matter what you call life. Now, I think that if you ask the question, anywhere in the universe, what would it mean to say that life has arisen on this planet? I think for that, to answer the Freeman-Dyson question, the answer to that is self-replication. Self-replication is the single step that gets natural selection going. Once you've got self-replication, then at a very, very crude chemical level, you've got the possibility of natural selection of molecules in the sea or something like that. Nowhere near getting bodies yet.
Yeah.
We're just getting a differential survival of copying entities. Wherever in the universe coded information arises, coded information meaning self-replicating entities, probably molecules, but anything that's self-replicating, where there's more than one kind of replicator, such that there can be a mixed population of them, such that one of them is more successful at replicating than the other, and therefore tends to outcompete the other in the population of replicators. Once you've got that, then you've got the origin of natural selection, and then the whole crane gets going, the whole process gets going.
But as a physicist, I could say, well, you can't have that unless you can extract energy from the environment. You can't self-replicate unless you have a mechanism for taking external energy and harnessing it. So in some sense, before replication, you kind of have to have metabolism.
Well, this is the line that Freeman-Dyson is plugging. And that may be true. It may be, I mean, all I would say about that is that self-replication, which is the key process, isn't going to get started unless there's a chemical precondition to make it possible. And you can call that metabolism if you like.
But you say until you have the replication, then what really defines life, which is natural selection in a sense.
Yes,
it doesn't happen.
That's when natural selection only can take off when you have self-replication. And to say that you need to have metabolism before, as I say, may be right, and that just means that we're talking about the difficulty of setting up the initial conditions under which replication can get going. I mean, the initial conditions for DNA to get going are much more complicated than that. So we're looking for whatever the initial conditions are, for whatever the precursor of DNA was.
But someone once said to me, I didn't get this myself, and I think we once had this conversation briefly, but I don't know if we did on stage. By that definition, you might think of fire as life. In a sense that fire, first of all, extracts energy from the environment. It self-replicates in the sense that you start a fire here, a forest fire here, it goes there, and it almost self-replicates in a way which is robust, in the sense that certain kind of trees burn hotter than other kinds of trees.
Yeah, well, you see, you've missed the key point there.
Okay, good.
Because imagine we've got a great prairie, and a forest fire starts there, and then a spark flies up and starts a daughter fire, and then another daughter over there, another daughter over there. That one then produces another, and that's a granddaughter fire. There's a great-granddaughter, great-great-granddaughter. So you've got fires proliferating all over the place. That's reproduction. It's only replication if the properties of the fire come from the spark of the ancestor, come from the parent, which you know is not going to be the case. If, say, that fire is burning blue, it's because there's copper in the soil. If it were the case that a blue spark flew to the next place and started another blue fire. That's heredity. That's true replication.
But let me
but
be
that
the
doesn't
devil's-
happen.
I would say there might be kind of natural selections because hotter fires will last more effectively. So a certain kind of tree that burns hotter will last longer, and the daughter fires that'll survive more effectively.
But you're missing the point because the hotter fire, because a certain kind of tree, it doesn't go in the spark. It has to hit another tree of the same kind.
Well, yeah, but I'm saying the ones that don't hit the trees of the same kind don't survive.
Yeah, but
so there's a distribution, if you wish, of fires, and the ones that affect. I'm just trying to make you mad, but
look, listen to this.
It's working.
There are different. Some fires burn hotter than others. Some fires burn cooler than others. Some fires burn blue. Some burn orange. Some burn purple. And the reason why they're different is the trees,
is the materials
and the soil and the local materials there. It doesn't go in the spark.
Yeah.
If it went in the spark, that would be true heredity, and that's the key. That is exactly the point. That's what genes do, and it's what fires and very little else does.